the co-founder of Firefox OS, and I'm happy to be one of the high-level sponsors of it.
Thank you very much. Brendan Eich, our CTO, is someone I probably don't even have to introduce. He invented a couple of things in his career, amongst others JavaScript. Some of you might have heard about that. And if you have not, you will hear a lot more about HTML5 and JavaScript in our talk today. So we are here today to talk about HTML5 and in particular about mobile. If you look at the mobile ecosystems out there, and especially if you compare them and contrast them to what you see on the desktop, where today really HTML5 and the open web are the predominant way of delivering content to desktop devices, and you contrast that with what you're seeing on mobile, it's a very stark difference. Whereas on the desktop, everything is based on open technology and open standards where multiple companies implement a system that's compatible, where the same content can play on multiple implementations of the same standards. On mobile, you have these silos or jail cells, where as a consumer, at most you have the choice which jail you want to sit in, but it's a jail nevertheless. So in case of Apple's iOS, it's a completely Apple-dominated technology stack. All the technology choices, all the services, all the monetization, everything goes through Apple. And then you have the Google version of it and a Windows version of it. But it's all in the end the same, where you have one vendor completely controlling the experience.
It's a very shiny jail, though.
It's a very shiny jail. It's a nice jail, but it's still a jail you can't really escape. And this also in particular affects people once they have bought an app. As a developer, you have to develop apps for all these different systems because they're incompatible, they have different technology stacks. And then the consumer, once you have bought the app on one particular system, you can't really easily switch anymore. Your content is locked to that system. You bought it from one vendor, Apple or Google, and you bought it based in Java or Cocoa or some strange Microsoft technology, and it's kind of captured in that system. You cannot easily switch between these back and forth.
So I'm also a founder of Mozilla.org, where we launched in 1998 from Netscape as it was going down. We had an escape pod that managed to land on a planet, and we eventually created Firefox and took back the web. If you remember in 2004, coming out of the IE nuclear winter, we actually showed that you could have a competitive browser that grew share against Microsoft, something that had never been done before. And we restarted the modern world of open standards and a more balanced market structure. So you have competition driving cooperation in order to get developers who are really the prize here. There are like 8 million developers that know the web stack. There's millions of them on GitHub and other places hacking in the open. And they are the biggest cohort of developers that everybody wants to win, but the only way to win them is to standardize and make the web better. And that's exactly what Andreas was talking about, breaking down the barriers of those jails. So we did it on a desktop with Firefox. We're going to do it again. We're doing it again with Firefox OS.
If you look at HTML5 as a technology platform, really what's so powerful about it is it's ubiquitous. And it's ubiquitous along multiple axes. First of all, you find it on all these different classes of devices. Its history is mostly rooted on the desktop, but already today, every smartphone is web-enabled, every tablet is web-enabled. And as technology is pushing in other fields of electronics, like cars and fridges and watches and whatnot, all these devices are usually all web-enabled. So it gives you a tremendous amount of reach across all these different categories of devices. But at the same time, also, you're not locked into any specific vendor solution. So if you go to Amazon.com, it doesn't matter whether you use Mozilla's browser, Firefox, or Google's Chrome, or Safari that Apple makes. You have the same experience. You can access the same content through the browser since it's all based on open standards. And that's really the true power of HTML5. So you're not locked into one platform. So whenever someone tells you, like, I want you to make an HTML5 app for Chrome or for this or for that, you should be very suspicious, because that's not really utilizing the core strength of HTML5, which is that you can make content once and you can run it across all these different platforms. So today, what we're telling you really is, we want you to make HTML5 apps. We want to explain to you why it's powerful and why that makes sense for you. We will speak a little bit about Firefox OS as well, which is our specific implementation of mobile HTML5. But everything we say here really applies to all HTML5 implementations. So the true power behind HTML5 is that you can target one technology stack and cover all these different classes of devices across all these different vendors.
So I was at an event in Palo Alto yesterday talking to a bunch of people, and some of the UX designers talked about how hard it is to do different screens and adapt to different toolkits. The web is by far the most adaptable platform I've seen. It's not a free lunch. When you get Retina displays, you need higher resolution images, but those are much easier for developers to create than to rewrite all their code. And what we've done in doing Firefox OS is we've stripped down the stacks that you see on iOS and Android, let's say, to remove the middleware layer that was used for native apps or for Dalvik apps. We don't need that layer. We can just use the web. That means, as you can see on the right side, there's a thinner stack, and it's based on standards. It's not just Firefox OS. This is really a pattern for a WebOS, a category that can include many different operating systems. And we think will. We have cooperation in the standards bodies with Microsoft and others. We expect developers, that big cohort of 8 million or more, are going to force all the vendors to keep innovating but also keep agreeing on the standards. So again, like Andreas said, when you hear about HTML5 for brand X, be careful. It has to be fed into the standards constantly and iteratively, and that's what we're doing. And the thinner stack helps us fit on a lower bill of materials phone. We're targeting the emerging markets and markets in Europe where people are coming off feature phones. We can't afford that middleware layer. It's actually an advantage not to have it. And we'll talk more about how we would do without it in slides to come.
So for the remainder of the talk, what we want to focus on is highlight some of the developments in the HTML5 arena and some of the new technologies that are available through HTML5. And this is particularly important for app developers because if you look back historically, we ended up in a situation where native environments, these proprietary jails of iOS and Android, have become really popular, mostly because in the past, mobile HTML5 was simply not competitive. So to close that gap, what Mozilla and others did in the HTML5 space is spend a lot of time on proposing new technology standards for device capabilities, and then also go actually implement those and ship devices with them. And this is how HTML5 is advanced. It's not a static technology stack. We can advance it, and we are one of the major players in these standards bodies that actually also pursue standardization on these technologies.
That's right. So when we started Boot2Gecko, Firefox OS's code name, we looked around at the standards bodies. We actually found some device standards that were kind of gathering dust. Opera and others were working on them, but they weren't really moving. And we started implementing them and iterating on the draft specifications. And we've pretty much finished covering the entire sensor space and device space with APIs you can access from JavaScript so that the web really is a complete platform. There was no reason in principle why the APIs that were unique to iOS and Android's native stacks couldn't have been in the web. It just wasn't done. It was hard to do two things instead of one. The various companies had interests in building up their native capabilities over against the web. We've finished that process of making the web be on the same playing field. And some of these standards are actually in last call, the status of the W3C, where they're almost an international standard.
For these standards and these new technology areas, it's particularly important to make sure that there is actually a standardization process behind these things, because you don't want to get caught in an environment where you make an HTML5 app that then runs in the end only on one system, because you are forced to use that specific vendor's technology approach to it. So this is why it's very important for us that everything that we put in our stack, for example, we pursue for standardization and we try to standardize it. And that's in the end actually what Mozilla has been doing the last 15 years in desktop as well. The way we advance the desktop web and the way the desktop web has become this competitive entity is that over a long period of time we have proposed extensions to it and we standardized them to W3C in collaboration with other vendors.
It's a tricky point because people think standards are slow. I mentioned how browser competition is more balanced now. That means we are moving faster. We're seeing people trying experiments that they tell their fine standards body colleagues about from other companies. So we get cooperation early and we try to make things agree even before the final spec is written so developers can test them. And this is actually succeeding. It's tricky in some areas like telephony, but we think it will happen there eventually too.
One specific area we're very excited about is payment for the web. And we think this is very important for premium content. There's a couple different ways how today we already monetize on the web, and advertisement of course is an important part of that. But making that a richer choice, giving additional forms of monetization such as payment is really critical to make the web fully competitive as native ecosystems and give developers a way to monetize their content. And the approach we're taking here is very, very different from the approach we see in iOS or Android or Windows Phone world, where you have these environments where like one vendor controls everything. They control how the payment works. They tell you how much they're going to charge you for selling something through their store. And they also very much control the content. Like you need approval from one commercial entity that the your app is allowed to be on those devices. So the web is really not an environment that works like this. There's no like central authority on the web. And we have set up the payment system that we have proposed to WebRTC for standardization in a very similar way, that there's a centralized protocol they're trying to standardize that says how payment works. And the device acts as a facilitator of payment. So you have a kind of content, and you have the choice to use the payment APIs exposed by the device. And there's various different payment providers that can plug into that. A very common one, of course, is the operator, who has an existing relationship with the user, but credit card companies can equally plug into these APIs. And it goes even further. You have actually the choice to use these payment APIs. If you decide that you have existing user relationships and existing credit card relationships, you don't have to use this. This is backed by the fact that once you build with HTML5, there's really no forcing function, as it's in this existing stores where you need approval and have to go through a store. Instead, simply you can deploy applications directly. You can download applications directly to the device. You can go to the store if you want to, but you don't have to. So this is a very stark contrast to many of the existing payment systems you see on these devices, where there's like one commercial entity behind it, and they, in essence, take over all the payment functionality, and you must work with them.
The gatekeeper. And of course, we support in-app payments too. So we're also working on a standard called WebRTC, which is in Chrome and Firefox. This is for video conferencing and audio conferencing and more. It's what you might rely on Skype for, or what you hope not to rely on Skype for next year. We think this should be a standard too. There's no reason, again, in principle, why we can't have good, responsive, real-time, multi-party communication, audio and video and beyond.
So WebRTC does the obvious things that you're expected to do, like exchange audio and video, but also actually has a capability that's not very obvious from just hearing the WebRTC name, and that's data channels. So in addition to transporting video and audio data, it can also transport arbitrary, just straight up data exchanged on a peer-to-peer basis between different nodes on the web. And this is where our talk is starting to get a little bit more visual and interesting. We will show you one of the things that you can do with this web applications.
So when you think about data communication, you should be thinking about multiplayer games. This is a video of actual screens running a game called Banana Bread we've developed in multiplayer mode using WebRTC's data channel to sync up the different players' views of each other.
And it's important to note that as everything else that you see in our talk today, this is all HTML5 and JavaScript. So that particular game was using WebGL, one of the core 3D technologies in the HTML5 stack. And everything that you see here today, all the demos, are running this HTML5. There's a lot of misunderstanding and kind of urban myths around HTML5 and gaming in particular. That's why I wanted to spend some time on that and also show you a couple of demos around this. The main core technologies you interact with, especially if you make very visual, interactive content, is HTML5 itself, but then also JavaScript and WebGL, which is the 3D standard used on the web. Now, initially, I want to talk a little bit about JavaScript because there's a lot of misunderstanding, I think, on the performance characteristics of JavaScript.
Really? No.
One of the questions I often get asked, like, so how do you compare yourself to something like Dalvik? And as you'll see in the numbers in a second, that's almost not a fair question to ask because we are comparing ourselves to native code. We want to see how good are we in comparison to natively compiled C++. We have left the Dalvik and these kind of technologies long behind. And that actually relates back to the things that Brandon was talking about of competitive pressure. The web is a very different environment than Android, for example. There's exactly one party implementing Android, that's Google. And there's no competition. If Google decides that Dalvik is fast enough, then that's as fast as Dalvik is going to go. We are not in this comfortable position. Our JavaScript engine competes with several other implementations of JavaScript that all implement the same JavaScript standards. And what we compete over is not how JavaScript works. We compete over how fast can you execute JavaScript. What is the quality of your implementation? This creates a very, very different environment than in these proprietary systems where basically the vendor chooses how fast it's going to go. We have to compete. And every time we are slower somewhere, there's some press article being written about that, and we are under pressure to actually fix that.
And we also do uplift the other parts of the web standards you need, like WebGL and WebAudio. But JavaScript is particularly compelling because we found a way to compile your existing C++ or C code base. There are million-line code bases like Epic Games, Unreal Engine 3. These are C++. They are not going to be rewritten for the web. They need not be rewritten. With the Emscripten compiler, they can be automatically compiled into a dialect of JavaScript we call Asm.js. This is just an assembly language like subset of JavaScript that gives us predictable performance, no pauses, no GC, garbage collection, no type speculations. Gives us really good speed, very close to native. When Mozilla tries to make the web be the platform, we're serious. We don't have a native development kit. We use JavaScript as the assembly language, and we can make it super fast. And we'll be demoing that.
So I wanted to briefly show a couple of numbers, just what this means in practice. On these graphs here, you see a couple of different browsers running code that was compiled with Emscripten, that was originally C or C++ code, and we have compiled it to JavaScript. And we don't change that code. So it's just straight up C++ code that we have downloaded somewhere, and we took this tooling Emscripten to compile it to JavaScript. And this JavaScript runs actually in any browser. So you see benchmark numbers for Safari, Chrome, and Firefox here. Firefox, of course, being our own browser. Now, the one little twist to this is that we compile this code actually to a subset of JavaScript. So it runs everywhere, but for browsers that understand this subset, which we're currently standardizing as part of Thesis 39, which is the standards body around JavaScript, then because it's a subset and it avoids certain expensive features of the language, it can be compiled particularly effectively. So you can see in this graph here, if you look for a second at the light blue one, which is Firefox, you can see that that blue bar, and small is better in this case, is actually very, very close to 1.0, which means that that's the native code. That's like as fast as we can run that code by steadily ahead of time compiling it with the best compilers we could find and running it on an ARM system.
This is showing slowdown from native. So again, 1 is native speed. And you can see we're touching 1 on some of these. Like Box2D, we're 1.3 times slower than native. And we're safe. We're not prone to malware like unsafe native code would be. There's no plug-in scary dialogue that users face, which causes user acquisition loss. This is real code that you can automatically cross-compile to the web at high performance.
And then, so we have seen the performance here. This is as fast as native, or close enough to it. And these are real examples of code. So Box2D is a physics engine, as you would find in a game, for example, similar to Bullet, which is also a physics engine. Now, the second big advantage is that this is not some Mozilla proprietary technology. So I'm not asking you to use Emscripten so you can make Firefox OS games. That is not really a scaling proposition. You don't want to make a game for one specific implementation. So what we are doing here is it actually runs on any given browser. So we have numbers here for Chrome and Safari. In some cases, they are a little bit slower since this was a technology we initially proposed and initiated, and they are now in the process of catching up, as I described to you earlier, because we are faster on some things. They're under pressure now to be as fast. But even then, you can see that in some of the cases, Safari, for example, is only maybe like 2x or so slower than us on running ESM.js code. So as in all other parts of the web stack, over time, I expect these browsers to pretty quickly converge. In the end, no other browser vendor can afford to be massively slower than us on a game, for example. So you should see Safari, Chrome, and IE from Microsoft pretty quickly converge on the same kind of performance characteristics that we have.
Andreas mentioned the standards body that we work in JavaScript on. We have a friendly rivalry with some of the other JavaScript engine implementers, like the V8 team at Google and the JavaScript core people at Apple, and all these performance gaps get filled. This is the story of the last 5 years since I started working with Andreas. We've been bringing JavaScript performance up 2 orders of magnitude, and everybody is in a constant race to catch up with everybody else, and the developers are winning from this.
And if you're interested in how does this compare to Dalvik, for example, I encourage you to Google around a little bit for Emscripten and its technology. We have actually some numbers up on our website. They compare this to Dalvik. So Dalvik is somewhere off on the side. To the right, since again we are comparing here against the fastest possible native C++ code, not really some other VM running. So this is enough about dry numbers. Let's look at some of the demos and what this looks like in practice. So Brandon's going to demo you here one of the games that we have ported with this Emscripten framework, and we will be showing this on a regular Mac laptop here. And this is actually running in the latest version of Firefox Nightly, which is basically our developer branch of Firefox. And as Brandon already said, this is completely running without any plugins or anything. This runs just this HTML5 JavaScript in any browser. And you're seeing it in Firefox, but you can also run the same demo in Safari and in Chrome.
For my age, I have mad skills. Here we go. This is the Unreal Engine 3. This is Unreal Tournament, the Sanctuary level. There's some bots down here. There they are. So that was pure JavaScript, WebGL. That was not possible even a year ago. We showed that at a game developer conference, and the frame rate's only getting better. We have solid 60 frames a second. We're getting into the next version from Epic called Unreal Engine 4. It's an awesome engine. And we're talking to other game publishers. And again, the point is you don't have to rewrite your code. If you're one of these game developers, you have a big code base, we have a compiler for it. We're not telling you to rewrite for the web. We're not telling you to rewrite for Firefox's version of the web. This is about standards and tools and existing code bases.
If you're interested in this particular demo, so this is available from the site of the vendor. So you can Google a little bit for the Unreal Engine and Mozilla. You'll find a blog post that's up where you can see the video, but also actually there's a link to the site of the vendor where you can play this in your own browser and you can try it in the different browsers that you might use. There's some really key advantages if you combine the power of using existing technology stacks like C++ and OpenGL, and you combine it with the ability to directly compile that to HTML5. So there's actually a little story up on the web that you can read where the engineers on our side who met with the manufacturer of this game engine to port this game, I think the whole game was ported in something around like 3 or 4 days, where they basically met with the vendor and they had an existing C++ code base that used OpenGL to render content. And they run this to the unscripted toolchain. There were a couple of bugs we had to fix in the actual toolchain, but it was actually very easy to port this over. And if you see this from the perspective of a developer, which many of you are, you really have to kind of pause for a moment to realize the power of this, because it means that this a simple step, you can take your existing content, and we're not talking here about like block graphic and simple text. We're talking about an immersive 3D games, audio, and you can very easily transport this over on the web stack. And it runs on this Mac here, and it runs on any other browser, it runs on PCs, it runs on like HTML5 enabled TVs, and it spans everywhere where HTML5 is. And this is really the power when you use these very ubiquitous technologies that you're suddenly no longer locked into one specific content system. Now it's important though also that this is not just for desktop. So we have demoed this on desktop because that's where most of the horsepower sits right now, and it's very easy to show this like very immersive 3D games with 60 frames per second on a desktop system. But we are very much also working on bringing this to mobile, and that's the next demo I'm going to show you. So we have a little video here that's recorded in one of our Firefox OS devices that shows a game, and this is Where's My Water, a very popular game made by Disney. And it's a similar story that this game was made with C++ and OpenGL, and we helped Disney very quickly to port this over very few days over to a Firefox OS device. So I'm going to explain a little bit while this runs here. Like you're seeing, so as you saw, it's this Firefox OS device. This game is installed on a device. HTML5 has these days a lot of offline caching capabilities, so this game actually was not loaded over the wire. There's also a frequent misunderstanding around HTML5 that, oh my god, I have all of this to be connected. That's really a thing of the past. So this game is actually locally installed. It uses the offline cache to be always available. So the consumer can play it on an airplane or when there's no connectivity. This is particularly important for some of the regions of the world we are particularly focused on, which is like emerging markets and places where there's a lot of volume, a lot of people are moving to smartphones. And as with the game we have seen here that was based on the Unreal Engine, there's essentially no changes we had to actually make the game code. We just took the existing C++ and OpenGL code base and compiled it to the web. We're showing this to you today on a Firefox OS device because that's what we use to show HTML5 content. But you can use the same content, you can play it in existing devices, in like Android and iOS, to the degree that they support WebGL. I think someone here just won finally, the Croco here can finally go and shower itself. So you have seen here that the technology is there already to port all this content over. It's not constrained to desktop. It's also equally available on mobile these days.
So I usually close these talks with some rallying cry like the web is the platform, and it sounds kind of cheesy. The web does have the widest reach. Now, people were doubting a year and a half ago. They were saying, but native, you have apps that are getting hundreds of millions of users, they're hits in the stores. A lot of them are based on the web standards. Even when Facebook said they were going native, it turns out their native app in iOS had mostly web views, apart from the chat and the wall app widgets. So the web is winning. People don't see this, but we do in Mozilla. We see the standards progressing. We see covering all those device sensors. We see JavaScript performance going through the roof. We're way past things like Android Dalvik. We're right up against native code speed barrier. And that's our native development kit. So when we say the web is a platform, we mean it, and we're making it come true, and we're making it come true for everybody. It should help developers span all devices, all OSs. It's not just about us. We just want to get Firefox OS out there to show that it can be done and to get people something that gives them real choice and innovation on the web. And that's Mozilla's mission. Thanks very much.
Thank you.